NASA Spacecraft takes GPS to new heights. Presented by Science at NASA. As any backcountry hiker knows, Global Positioning System, or GPS, trackers are crucial for navigation. But they can also be a little finicky. Units sometimes lose lock when you walk into the shadow of a canyon wall, when you point the units at the ground, or even when you make a sharp turn. Now imagine a GPS system flying through the vacuum of space at 22,000 miles per hour, rapidly spinning 43,000 miles above the surface of the blue planet below. Would it work? Turns out the answer's yes. NASA has developed a GPS navigation system for the newly launched MMS satellites that operates under these incredible conditions. On March 12th, the 4 spacecraft of the Magnetospheric Multiscale or MMS mission left Earth on a mission to investigate the physics of magnetic reconnection. Magnetic lines of force cross, cancel, reconnect, and bang! Magnetic energy is unleashed, with charged particles flying off near the speed of light. This process happens in many places. It sparks solar flares on the Sun, as well as powering magnetic storms near Earth. Understanding how magnetic reconnection works requires the 4 spacecraft to fly in a tight pyramid formation through Earth's magnetic field. Positioning is crucial. Speed and altitude are not the only challenges for the spacecraft's onboard GPS units. In addition, the MMS spacecraft spin. Each one makes 3 revolutions per minute. Spinning adds a whole new dimension to trying to figure out where you are, said Ken McCoy, MMS GPS Navigator Product Development Lead at NASA's Goddard Space Flight Center. We have 8 GPS antennas on each spacecraft. As the spacecraft rotates, we have an algorithm running that allows us to hand off from one antenna to the next without losing the signal. During the first month, the team compared the MMS Navigator system with orthodox ground tracking systems and found Navigator to be even more accurate than expected. At the farthest point in its orbit, some 43,500 miles away from Earth, Navigator can determine the position of each spacecraft with an uncertainty of better than 50 feet. The MMS Navigator system exceeded all of the team's expectations. At the farthest point of the MMS orbit, of 43,500 miles, Navigator was able to receive signals from the GPS satellites and perform onboard navigation solutions. At the lowest point of the MMS orbit, Navigator traveled at velocities over 22,000 miles per hour. In comparison, GPS satellites orbit at 12,550 miles away from the Earth and travel at 8,600 miles per hour. And most satellites using GPS receivers are in low Earth orbits at altitudes between 110 and 1,250 miles. It's fair to say the MMS GPS is far out and moving fast. This system will be even more important during the second phase of the MMS mission, when the orbit will double in size and travel all the way out to 95,000 miles from Earth. Thanks to this extraordinary GPS tracking, the work of understanding magnetic reconnection can begin. Stay tuned for updates with precision from science.nasa.gov.